We will be discussing about probable error. So, what is probable error? Probable error is a difference occurring due to taking samples from the mean of population, right? So we know that we take samples from a population, right, which is representative of a population. If you take any number of sample from this population and have the correlation coefficient calculated, so we will be most probably getting different values for correlation. Am I right? So in that case, probable error will tell us a limit in which all this correlation coefficient may lie in. So this can be considered as a measure which tell us what is the extent to which correlation coefficient may vary in a population if you are taking different population, and it is also used as a tool which help us to know statistically whether the correlation coefficient which we have calculated is significant or not. So we'll see in detail what it is. So we could say probable error is a measure which, when added to and subtracted from, give us two limits. Within this limit, it is probable that all the results of the sample pairs selected from the same population will fall in from same population. Maybe one sample will give us a R value which is here, the other one may give us a R value which is here. But the thing is that if the values, or if the samples are selected from the same population, it will always give us a value which lies between this particular R minus P and R plus P. So if probable error is added to or subtracted from the coefficient of correlation, it would give us two such limits within which we can reasonably expect the value of coefficient of correlation to vary. Right. So we could finally say PE, or probable error, is a statistical measure which measures reliability and dependability of the value of coefficient of correlation. Now we'll see how it is done, right? So how can we say the correlation is reliable or dependent, right? So for that, how we could calculate probable error? So probable error is calculated using the following formula, where we have 0.674 into 1 minus r square, where r stands for correlation, right? Correlation coefficient, and n, as you know, it is number of pairs of observation. So what are the uses of probable error? It is used to determine, we have already said, it is used to determine the limits within which the population correlation coefficient may be expected to lie, right? And it may, I already said, the correlation may vary for different type of sample which is taken from the same population, right? Now, second point, it can be used to test if an observed value of sample correlation coefficient is significant of any correlation in population. Right. Now we will see how this significant levels comes in, or how we could say it is significant or not. Interpretation of probable error. So this is how this is where we'll see how it is significant. When can we say this coefficient of correlation is significant? If coefficient of correlation is less than probable error, it is not at all significant, right? So if you get a value which is less than this probable error value, it is not at all significant. Second point, if coefficient of correlation is more than 6 times its probable error, the correlation is significant. And last point you should keep in your mind is that if the probable error is not much, and if the coefficient of correlation is 0.5 or more, it is generally considered to be significant. So if it is 0.5, correlation is 0.5 or more, and probable error is very feeble, right, or maybe very low value, we could say this particular correlation coefficient is significant. So we'll have a small quick example, and we'll just calculate what is the probable error. As you know, we have a question wherein we have a correlation already given, which is negative 991, and we have n at 6. We are supposed to calculate probable error. So for calculating probable error, we need only what is coefficient of correlation, what is n. or number of observations, right? So we know that the formula for calculating probable error is 0.6745 multiplied by 1 minus r square divided by root n, right? So we'll substitute the values 0.6745 into 1 minus, in this case it is negative 0.991 squared divided by root of 6, right, which gives us the value 0.6745 into 0.018 divided by, you could say it is whole divided by 2.449, which finally gives us the value 0.005. Now, so if you look at those two values, we got probable error as very less value. Probable error is 0.005, and we already have our correlation coefficient, which is point 0.9 negative 0.991. So we could obviously say it is more than 6 times maybe, or the value of correlation coefficient is more than zero point 0.5, and the probable error is very feeble or very low value. We could say this correlation coefficient is significant. Okay, so this is very simple. Uh, Hope you understood it. If you have any doubt, you please ask me. Thank you. Have a nice day. We will see you with another video.